Hello everyone, this is Marwan Omar and my talk is on autonomous vehicles navigating the legal and regulatory issues of a driverless world. So let's get started. Here's our agenda. We will talk about SAE levels, physical ecosystem, strategic partnerships, legal issues, regulatory, product liability, cybersecurity and data privacy, intellectual property, case study on QoS ABS in public transportation. Introduction. 10 million autonomous vehicles are expected to be to hit the road by 2030. So we are expecting that 10 million autonomous vehicles will hit the roads by 2030. In 10 years, fully autonomous vehicles will be the norm. AVs, meaning autonomous vehicles, will generate a $7 trillion annual revenue stream by 2050. Widespread adoption of AVs could lead to a 90% reduction in vehicle crashes. History of autonomous vehicles. Introduction of cruise control. That was in 1948. FCC allocates 75 megahertz of spectrum to dedicated short-range communication. That was in 1999. And by 2009, Google begins self-driving car project, or before then in 2007, teams create vehicles that self-navigate a 60-mile course as part of DARPA Grand Challenge. Then in 2012, Google's autonomous car passes a 14-mile driving test in Nevada. 2013, Mercedes and Infiniti produced cars with radar sensors and some autonomous driving features. Also, NHTSA releases initial policy on autonomous vehicle. In 2015, Tesla releases its autopilot self-driving mode. 2016, major acquisitions and partnerships: GM and Cruise Automation, GM and Lyft, Toyota and J-Bridge Robotics, Uber and Volvo. 2016, NHTSA issues guidelines for testing and deployment of autonomous vehicles. 2017, NHTSA issues revised safety guidelines for autonomous vehicles. SAE levels of automation. Level 0, no automation, 0 autonomy, so the driver performs all driving tasks. Level 1, driver assistance, vehicle is controlled by the driver, but some driving assist feature may be included in a vehicle design. Level 3, partial automation, vehicle has combined automated functions like acceleration and steering, but the driver must remain engaged with the driving task and monitor the environment at all times. Then in level 3, there's conditional automation. Driver is a necessity, but is not required to monitor the environment. The driver must be ready to take control of the vehicle at all times with notice. High automation in level 4, the vehicle is capable of performing all driving functions under certain conditions. The driver may have the option to control the vehicle. Full automation, the vehicle is capable of performing all driving functions under all conditions. The driver may have the option to control the vehicle. Now we have basic physical ecosystem of an autonomous vehicle. We have a global positioning system or GPS, light detection and ranging, LIDAR, cameras, video, ultrasonic, sensors, a central computer, radar sensors, dedicated short-range communications with receiver, not pictured here. Key physical components of autonomous vehicles. Cameras provide real-time obstacle detection to facilitate lane departure and track roadway information like road signs. And the radar waves detect short and long-range depth. LIDR measures distance by illuminating target with pulsed laser light and measuring reflected pulses with sensors to create 3D map of area. GPS triangulates position of car using satellites. Current GPS technology is limited to a certain distance. Advanced GPS is in development. Ultrasonic sensors uses high-frequency sound waves and bounce back to calculate distance. Best in close range. Central computer brain of the vehicle receives information from various components and helps direct vehicle overall. Then we have the DRSC-based receiver communications device permitting vehicle to communicate with other vehicles using DSRC, a wireless communication standard that enables reliable data transmission. In active safety applications, NHTSA has promoted the use of DSRC. Companies investing in autonomous vehicles. Vehicles operating in SAE levels of automation 1 to 3 are already in commercial use, and many companies are investing further in developing highly and fully automated vehicles. QLS, FedEx, NVIDIA, Microsoft, Apple, Audi, New Autonomy, Apple, 44 Plus, Ford, BMW, etc. Strategic partnerships, BMW, Intel, and Mobileye, Volvo, NVIDIA, Volkswagen, GM, and Ford. Recent developments, January 2017, QLS and Navia, in partnership with the city of Las Vegas, launched the first autonomous, fully electrical shuttle to be deployed on a public roadway in the United States. January 2018, Toyota announces e-Pallet concept vehicle, which is a fully electric autonomous vehicle that can be customized by a partner for applications such as food deliveries, pizza, ride-sharing, Uber, or storefronts, Amazon. January 2018, UDelv, a Bay Area tech company, completed the first delivery of goods by a self-driving car when it delivered groceries in San Mateo. February 2018, Hyundai announced that a fleet of its fuel cell electric cars made a successful fully automated trip from Seoul to Pyongyang. This is the first time a level 4 car has been operated with fuel cell electric cars. Legal issues around autonomous vehicles, regulations, liability, personal injury, cybersecurity and data breaches, intellectual property ownership, federal and state regulations. Federal Regulation of Autonomous Vehicles, Federal Motor Vehicle Safety Standards, the National Highway Traffic Safety Administration, or NHTSA, within the Department of Transportation, specifies minimum safety performance requirements for motor vehicles and equipment. Automakers must certify compliance before selling vehicles. Fully autonomous vehicles and some semi-autonomous vehicles would not meet current federal motor vehicle safety standards. In other words, if manufacturers seek to design vehicles without mirrors, bumpers, braking pedals, and other features required by the FMVSS, NHTSA can approve a limited number of exemptions from the FMVSSs. NHTSA also can approve importation of autonomous vehicles that do not meet FMVSSs for testing subject to conditions. DOT, Department of Transportation, released new guidance on autonomous vehicles in September 2017 titled Autonomous Driving Systems, a version of safety, replacing guidance issued in 2016 by Obama DOT. Guidance issue identifies 12 safety elements: 1, system safety; 2, operational design domain; 3, object and event detection and response; fallback minimum risk condition; validation methods; human-machine interface; vehicle cybersecurity; crash worthiness; post-crash ADS behavior; data recording; consumer education and training; and 12 federal, state, and local laws. Recommends that entities involved in ADS testing and deployment demonstrate how they address the 12 safety elements by publishing a voluntary safety self-assessment. NHTSA, the Federal Highway Administration, and the Federal Transit Administration have sought comments related to autonomous vehicles. And the deadline for filing all comments was March 2018, March 5. Federal legislation governing autonomous vehicles, congressional efforts underway to amend current law regarding regulation of autonomous vehicles. House and Senate bills have similar objectives, authorize NHTSA to issue more exemptions from FMVSS up to 100,000 vehicles per year within 3 years after enactment, require NHTSA to update FMVSSs to accommodate autonomous vehicles, require mandatory safety assessment, reporting of the elements similar to those in DOT's voluntary safety assessment report, and includes cybersecurity and privacy requirements, preempt state regulation of safety, but preserves state role to regulate licensing, registration, issuing insurance, and other traditionally state functions. Senate bill is on hold. 23 states and District of Columbia have passed legislation governing autonomous vehicles. 10 additional states have executive orders in place issued by their governors relating to autonomous vehicles. Arizona, California, Florida, Michigan, and Nevada have been most active. For a comprehensive review of state laws enacted, you can see ncsl.org. Product liability. Well, courts treat autonomous vehicles as drivers and apply a negligence standard or a sophisticated technology and apply a product liability standard. How will liability be apportioned? Fleet operators, providers, vehicle manufacturers, technology companies, software manufacturers, local governments responsible for maintaining infrastructure, product liability state laws, Florida, Michigan, Nevada, and District of Columbia shield manufacturers from liability for damages resulting from third-party conversion of vehicle into autonomous vehicle, except where damages are caused by defect present in vehicle as originally manufactured. Warranties and indemnifications should clearly define scope, responsibility, and liability. Responsibility for maintenance, repairs, and updates should be defined. Liability between automaker, technology company, and vehicle owner-operator should be defined. Responsibility for compliance with federal, state, and local laws and regulations should be defined. Cybersecurity. Potential attack gateways, electrical control units, airbag, advanced driver assistance system, engine, steering, brakes, etc., onboard diagnostics, dedicated short range, USB ports, passive keyless entry, remote key, remote link type app, tire pressure monitoring system, telematics wire, cybersecurity, a gating issue for safety in a connected and automated vehicle future. That's our source. Explanation of key attack gateways. The electronic control units are embedded systems that control one or more electric system or subsystems within a vehicle and are connected via an internal network. They control systems like the engine and transmission, steering and brakes, infotainment, lighting, etc. Risks arise when access to ECUs, usually peripheral ECUs like an infotainment system, are breached and malicious actors are able to access certain ECUs or the whole network. Vehicles today have up to 100 ECUs on board. Then OBD, diagnostic port. Every car manufactured after 1996 and sold in the US must have an OBD installed. The port was originally mandated to permit monitoring of emissions, etc. It's increasingly used to facilitate non-diagnostic features like enabling Wi-Fi or enabling an insurance company to track usage through attachment of a dongle to the port. These ports can provide a means of access for attackers into an otherwise secure system. Software glitches. Connected vehicles today contain more than 100 million lines of code. More code means more opportunity for bugs and mistakes. Glitches, even when inadvertent, can be exploited. No single source of knowledge of or control over source code. Software for different components of connected vehicles is being written by different developers, installed by different suppliers, and no one source has knowledge of or control over the source code. Increased use of apps leave vulnerabilities. Consumers are using an increasing number of smartphone apps to interface with their connected cars and help run certain functions. Researchers have already demonstrated weaknesses in some of these apps, likely to see spreading use of malware. Need for constant updates may be overlooked. With the increased use of connected features comes an increased need for continuous updates to fix glitches and help protect vehicles. This is a risk. These updates could be overlooked. There is a risk. These updates could be overlooked. or that malicious actors could infect routine updates. The same types of attacks that are possible in any connected device are generally possible in connected vehicles once access is gained. For example, denial of service attack utilizing controller area network bus system, remote access and control. In 2015 GP event, man in the middle attack, etc. The difference between attacks like these against common IoT devices and attacks within a connected or autonomous vehicle is the likelihood for increased risk to life and property in the vehicle context. 2015 white hat attack on a Jeep Cherokee led to the recall of 1.4 million vehicles and heightened risks. Researchers were 10 miles away when they took control. 13% of car buyers are no longer prepared to even consider a new vehicle without internet access. More than a quarter of car buyers now prioritize connectivity over features like engine power and fuel efficiency. 45% of US car buyers are reluctant to use car-related connected services because they want to keep their privacy. 43% of US car buyers are afraid that people can hack into their cars and manipulate the system if the car is connected to the internet. The key regulator with regard to cybersecurity and safety concern is NHTSA, which has incorporated the National Institute of Standards and Technology cybersecurity framework as part of a multi-layered approach it recommends for vehicle cybersecurity. NHTSA works closely with the Federal Trade Commission on issues relating to consumer privacy in connected and autonomous vehicles, but it mandates safety. Protecting intellectual property, industry traditionally occupied by OEMs for 100 plus years now, and includes IP conscious tech companies, software centric technology companies working with OEMs are leading to increased joint ventures and strategic partnerships. Who filed the most patents? Bosch, Audi, and Ford. Who owns the most patents? Toyota, Robert Bosch, GmbH, Denso Corp, Hyundai Motor Corp, General Motors. Areas of innovation, autonomous driving, driver assistance, telematics. Key technology areas, we have artificial intelligence. So in order for the AV to operate in a full range of environments with millions of changing aspects, that will need to be accounted for. It will require AI, which will allow the base level software to be developed and tested with the self-learning capability. Future area of litigation lawsuits will likely increase once there is a robust autonomous vehicle market to support them. Defense strategies, participate in joint defense groups where possible, inter-parties reviews like in Energy and CAT case, potential Section 101 motion for patent ineligibility, licensing patents, protecting IP and trade secrets. DTSA now provides federal cause of action for misappropriation of trade secrets. Trade secrets versus patents. Trade secrets can remain a secret and will not be published like patents. Trade secrets are protected at time of conception. Patents are limited to a 20-year term, and trade secrets can last until they become public. Trade secrets may require joint venture agreements to keep confidentiality. Trade secrets not as appealing for technology that can be reverse engineered. Waymo versus Uber case. Waymo sued Uber for trade secret misappropriation, alleging that former engineer took 14,000 documents, alleged that After Uber acquired the auto, it used more than 100 trade secrets to develop its LiDAR solution. Case settled in February of 2018 for 255 million or 34% equity in Uber. Take responsible precautions to maintain secrecy, manage employees, manage access to sensitive information, insurance consideration, autonomous. In 2020, the average autonomous car may proceed 4,000 gigabytes of data per day. And this is another slide. So this is the end of the talk. Thank you so much for the time and attention.